Mario with MI Microflight once again, and I have come back to this machine here. I sent emails to Trees. I have not received any response back. I was on their chat through their homepage with somebody, and I sent them the video that I did earlier regarding the this matter here. So since I have not received any response so far, I decided to just look into this myself, because I really want to get this machine going again, and so I got it going again. I don't know if this is going to hold. Um, uh, is going to hold safely, because what I had to do is basically reconnect that wire that burned, and there's a little piece underneath there, that little white part that. See if I can zoom in on this area here. And where's my tweezers? But anyway, there's a little piece there. As you can see, that little white part that's sitting there is part of this sheathing of this wire that got burned. And if I focus in on that side there, you can see how it's scorched. The whole right side of this green connector is scorched. So what I did is I took some voltage measurements, and sure enough, I was getting the 24 volt 24 volt is coming in from that black and red wire on this side here. That's the input, 24 volts, that's fed to this board. This board does output 24 volts back into the heater element of the hot plate of the bed, and it senses the temperature to whatever this is set to. Right now this is still set at 210 and 60, which is what I've been printing at via this thermistor connector here. So this is the thermistor connector. If we trace these two wires here, this goes to the thermistor on the hotbed, and that black and red wire goes to the 24 minus and plus 24 volt on the heating element of the hotbed here. So I've already run voltage tests, and it's feeding the 24 volt. Another thing that I've been monitoring is, you can see those LED lights. These boards are great in the sense that they have LEDs that tell you what's working or what's not working. That's a nice feature. But as you can see, that's blinking there, which that blinking that you see there, and then this other light just came on here on the light on this MOSFET here on the left hand side MOSFET that's on, and it just went off. That is feeding the 24 volts to the heating element of the bed, and so it's going on and off. So that's working as it should via this thermistor connector here that's sensing the temperature. So when this reaches 60 degrees, this should be going off, as it is. It's going off and on, off and on. And if we monitor the temperature here, 59 to 60, so when it's 59 it turns on, which is on. It just turned on here because it dropped 1 degree. So this is working on a 1 degree differential here with the setting here. So 60, it's maintaining 60 degrees, and as the table cools off, it drops to 50. It should turn on the 59, and it just turned on. So this is it's fluctuating on and off between 59 and 60 degrees, which is according to the manual. According to the manual, if you look at some of the guidelines here for the questions about the heat bed, this is also nice about this manual, that it gives you a little information, at least, that you can see what's going on here. It says, the temperature of the hotbed is if the temperature of the hotbed is abnormal, which may be caused by the damage of the thermistor of the hotbed, the normal display temperature is about plus or minus 2 degrees of the set temperature. Okay, so it's within those two plus and minus 2 degrees. This is fluctuating between 59 and 60, so that's 1 degree. And as I just showed in this video, that MOSFET all the way on the left that's triggering the voltage to the element of the hotbed, it is turning on and off. Now that should go off when this reaches 60 degrees. 60 degrees. So when it drops to 59, we'll just wait till it drops to 59. 59, that should trigger again. So it is fluctuating and it's working. As I think it should work, but I'm still not convinced. So I've been monitoring this print very closely, and the bed is pretty warm here. Unfortunately, my thermometer here, I have this thermometer. It's not giving me the same temperature. It's not reading the same temperature. I don't think this thermometer is that great. This is from Turnigy. I got this from Hobby King, but I don't think it's doing the. I don't think it's reading it properly. So I need a much better thermometer here, because this is reading 60 degrees Celsius, and this is not giving me that reading. This should give me that reading when you position this as close as possible to the surface here, the hot bed. But it's not giving me that. It's giving me around 32, 31. And this is giving me much better readings here when I put this up against my LED, high power LED here lamp. Oops, let's see, right there. Well, that's going to 42, 40, 38, somewhere around 40, 42, 42, somewhere around 42, 42 degrees, I think, something like that. But it's a lot higher than what I'm getting from here, from the surface here. So either I need a better thermometer. This is, okay, so 31, this is fluctuating between 31 and 32, something like that, which is not nowhere near close to, the 60 degrees that this is reading from direct from the thermistor that's mounted at the center of this table underneath the bed. But this seems to be working just fine. That other LED that we see here is going to the hot end here, so that's triggering the heater of the hot end, and also that also has a fluctuation of 2 degrees between 210, 211, 209, and when that 209 drops, that starts flickering, to turn on the heater again, and it maintains that cycle, on and off cycle, and that's how you maintain consistent heat on anything that is heat related. Clothes, irons also work on the same principle, on and off, so it's a safety feature when it works properly. Okay, so having said all that, giving that just as an introductory to the issue that I've had here, my take is that after reconnecting this and getting finding out that this is outputting the right voltages, and just going through this process that I went through, from a logical and troubleshooting standpoint, I'm assuming that this wire right here was loosely connected to this terminal here, and the reason I say that also is because when I went to unscrew this, before I unscrew this, I put my tweezers here. Of course, everything was turned off, from the AC was removed. I pulled this wire and it just came out really easy, which should not be able to do that if the set screw, if this was installed properly. So I think this is at the factory. Maybe it wasn't installed properly, and the wire was just floating there, kind of just barely making contact with the surface, which could lead into 24 volts just sparking here, and the spark gets hot to the point that it starts fraying the wire. That's one possibility. The other possibility is that there was something wrong with the thermistor. It was not sending the proper. It was not telling the board to disconnect this when the temperature was at 60 already. So it kept increasing the temperature to the point that it burned the sheeting on the wire here. And as I said earlier, there's a little piece of that sheeting that's right there. I haven't pulled it out, but that's, and then the smoke from the burning of the sheeting got embedded in the adjacent wires, which are the ones that lead to the hot end heater. So I thought that was also burned, but it's not. It's I believe it's just from the smoke and the residue from the burnt sheeting that got into these adjacent wires. So I'm doing this video because, like I said, I wanted to get this machine working again. I really want to get these parts done, and I want to use this machine for other things. And I just couldn't wait for two trees to get back to me. So I'm going to go with the assumption that that wire was loosely connected to this terminal here, and that was the reason for this. But I would like to, like I said, I don't trust this because it may be maybe something a little bit more serious than that. The thermistor, if this thermistor is not working properly, especially after heavy usage, it is possible that it wasn't disconnecting this MOSFET from sending voltage to the heater, and that heater was just getting hotter and hotter and hotter to the point where this wire was getting also hotter and hotter because it's drawing more current through that wire. So that is a possibility. The other logical thing that we should consider for anybody that does electronic troubleshooting is that notice that this burn, the sheeting burned on the negative side of the this power distribution wires here. The red one is intact, which is the positive end, and so only on the negative is where this happened. So I mean, the machine is working. This is a little bit hotter than what I'm typically used to on my Anycubic i3s and on my monoprice and my own machines. It is unfortunately I don't have a thermometer that I can measure a true temperature here, but it is maintaining 60 and it is maintaining the 210 there with consistency. And once again, if that drops to 59, that MOSFET does turn on. Thus, it is turning on the voltage to the element here on the hotbed. And it just shut off there because this just went up to 60. So the thermistor is working from that point of view. But like I said, I just turned on the machine because I had it off for a while, and then I turned it back on, and then I reconnected that. Now that wire is set, is not moving. As before, I just pulled it out, really easy. So that could have been the issue. But I'm not relying heavily on this board, and so I'm going to keep a hawk eye on this machine for a while, and just let it run. I mean, this should not have issues with that. Thermistors, I mean, things get worn out, after heavy usage. I mean, that's typically how some of these things they tend to go. Nothing remains at the same state as it is, when they're brand new. So I do understand that, and with common sense, you can assume that after a heavy usage, those items, such as the thermistor or anything that monitors heat, is going to give out at some point. But I just received this machine not very long ago, and it's not like it's been going through months or even weeks, to the point where you can say, that component failed because of really heavy usage. I mean, I have been printing here almost daily since I got it, but it hasn't been months or like I said, or years, so. I mean, I have printed with a lot more consistency and a lot more usage on my Anycubic i3 Megas, and I've never had issues with the thermistors. I have had, like I said in my other video, issues with the power supplies, the capacitors failing. They dry up and then they bulge up, and then or they lose their capacity, and then you have to replace those. And once you replace those, you have a brand new power supply again that's able to output the correct voltages. This is a 24-volt system. My Anycubics run on 12-volt power supplies. And it's 24-volt because it's a bigger machine. It's got bigger plates, so you need to use a little bit higher voltages to maintain consistency in the distribution of heat, and just because it's a bigger machine. So this is what I just found out, and this is how I resolved this issue on my own, and hopefully Two Trees can address this issue, with me. Um, I'm hoping that this board will maintain its consistency as it is right now. But like I said, I'm not trusting. I would like to get another board just to replace this one because that connector is like really scorched on the side, so it's not you know it's not the same, and I don't know how well this connection is going to last here on this side because this was originally loose, and as I pulled the wire, like I said, and then I started undoing this, and I noticed that wait a minute, this was just almost floating there. So yeah, we'll see what Two Trees has to say. Hopefully they'll write to me. But so far, no response.